Integration by parts is a topic we're going to do today. And how is it done? It's a technique used to integrate an expression that comes in form of a product. What do I mean by that? From the differentiation techniques, we have product rule, from which we derive a method of which we can integrate the answer we get after finding the derivative of a product. In the other words, when you differentiate a particular function that is a product, the final answer can also be reversed to the original question, and this method involves integration by parts. To do that, let's go to a recall method of differentiation of the product du dx. We said it is u dv dx plus v du dx. By differentiating a function with this formula, we get our derivative. So what if we are to return the derivative back to the original function? We use the techniques called integration by parts. How is that done? We are going to derive the formula in this perspective to do that. Suppose we multiply both sides by dx, we are going to have du dv equals u dv plus v du. After multiplying by dx, when we multiply these by dx, they cancel out, and they cancel out. So we have this. To remove the d's, we introduce an integral sign. So we have integral of d u v equals integral of u dv plus integral of v du. So this cancels the integral d, and we have u v equals integral of u dv plus integral of v du. Bringing v du to the other side, and we have u v minus integral of v du equals integral of v du. So this technique, or rather we write it as integral of u dv equals uv minus integral of v du. This technique is called integration by parts. Let's take, for example, evaluate integral of x e raised to power 3x dx. This comes in form of a product because this is x multiplied by e raised to power 3x. The technique says let u equals x. If u is equals to x, then we would say the v will be equals to e raised to power 3x dx. E raised to power 3x dx. The v equals e raised to power 3x dx. We would say this. So thereafter, we find du dx, which is equals to 1. So which is equals to 1. After finding the derivative, we have not integrated at all. We only found the derivative of this. Recall from differentiation that to find the derivative of the variable, we have a n x n minus 1. We got for this x, which is 1. So which implies that the u is equals to dx. Conversely, we have dv equals e raised to power 3x dx. If we are to integrate this side, just dv to get our v, we have v, right? If putting integral sign, we remove the d. Then trying to integrate this, we use a different technique, integral of e raised to power 3x dx, where we say let a equals 3x. So dA dx is equals to 3. So that dA will be equals to 3 dx. So from here, we are making dx the side of formula. So dx is going to be what? dA over 3. So going to this, we have v equals integral of e raised to power a the a over 3, which means that the a over 3 has been substituted for the x in that expression. So which is v equals 1 over 3 integral of e raised to power a dA. And the integral of e exponential any variable is always the same. So we have v is equals to 1 all over 3 e raised to power a. So continuing from here, meaning v is going to be what? 1 all over 3 e raised to power 3x, since a is 3x. Now we have gotten our du dx, our v as well. Let's go back to the technique that says integral of u dv is equals to u v. Where is our u? Our u is equals to x times v, which is over 3 e raised to power 3x minus integral of v. Integral of v, where is v? Our v is 1 over 3 e raised to power 3x du, and don't forget du is now equals to dx. So we have this is equals x over 3 e raised to power 3x minus 1 over 3 integral of e raised to power 3x dx. So which implies that we have x all over 3 e raised to power 3x minus 1 over 3 into brackets 1 over 3 e raised to power 3x, just like the way we did for this. So then we have x all over 3 e raised to power 3x minus 1 over 9 e raised to power 3x plus c. Or probably you can factorize to get better expression, a smaller expression. So we have 1 over 3 x e raised to power 3x minus 1 over 3 e raised to power 3x into brackets x minus 1 over 3 plus c. So this technique is called integration by parts. We are going to bring more questions on integration by parts for you. Thanks for watching our video. Subscribe to our YouTube channel, please.